In this video, we're going to take a look at another example of a jointly continuous random variable. So here we have gasoline is to be stocked in a bulk tank once at the beginning of each week and then sold to individual customers. Y1 is the proportion of the capacity of the bulk tank that is available after the tank is stocked at the beginning of each week. Limited supply, so that value of Y1 is going to vary week to week. Y2 is the proportion of the capacity of the bulk tank that is sold during the week. Y1 and Y2 are both proportions, so both are going to take on values between 0 and 1. And how much we sell, Y2, we can never sell more than we have available, right? So our joint density function is going to be given by this right here. So it is 3 times y1 whenever our values of, whenever 0 is less than or equal to y2, which has to be less than or equal to y1, and y1 needs to be less than or equal to 1. So both of those will be ultimately between 0 and 1, but y2, more specifically, is actually really between 0 and y1. All right, so we're going to find the probability that less than 1/2 of the tank will be stocked and more than 1/4 of the tank will be sold. So let's get a little bit of a handle on what this graph looks like. So our value for y1, the largest value it could take on is 1. Right? So it could take on this value of 1. When our value of y1 is 1, the value of our density function is going to be up there at 3. And the value of y2, it can only go up to the value of y1. So when y2 is 1, then it has to be the case that y1 is also 1. But really, down there on that floor, we're having something that looks kind of like this. And so our graph looks kind of like that, right? So it's that surface, it's kind of this wedge shape projector kind of thing, right? So that is our surface, and we want to find what is the probability that our value for y1 is less than 1/2. So we have 0 less than equal to y1 less than equal to 0.5, and that we have more than 1/4 of our tank stocked. Right? So 0.25 is less than or equal to y2. Actually, it says more than 1/4, so maybe we'll take out the or equal to. All right, so that's what we want to find. Now here, because of the way the problem is set up, we can, if we're looking at the probability that our value of y2 is more than 0.25, it will only be more than 0.25 if our value of y1 is actually also more than 0.25, right? So we can't sell more than 25% of the stock if we don't have at least 25% of the stock available, right? So this here, we actually really want to rephrase this as we want the probability that 0.25 is less than or equal to y1. It's less than or equal to 0.5. And our value of y2 is greater than 0.25. All right, so let's look at our double integral that we'll have here. Our double integral that we're going to have here. So our values for y1, they are going to go from 0.25 up to 0.5. All right, so those are our values for y1. Our values for y2, they're going to go from 0.25 up to, well, we can only sell as much as we have available, so they're only going to go up to whatever the value of y1 is. And our function, density function that we're looking at is 3y1. Now in reality, we would be going off to infinity on the second one, like in a sense, right? Well, yeah. But we only have non-zero values in this range, right? So we can restrict our attention there. All right, so we're going to integrate with respect to y1 first, with respect to y2 first, right? So we're kind of looking at this piece. So we're going to integrate 3y1. We're going to integrate that with respect to y2. So that variable y1 we treat as a constant. And so when we integrate that, that will become 3y1 y2. And that's going to be evaluated from 0.25 up to y1. And so we'll get 3y1 squared, minus 3/4 y1 dy1. Right, and so now we're going to integrate this with respect to y1. Right. And so when we do that, we're going to get we'll get this first part is going to integrate to add 1 to the power, divide by the new power. The second piece will add 1 to the power, divide by the new power. So we'll now have 3/8. And we're going to evaluate all this from 0.25 up to 0.5. And when we do that, when we plug all that in, we're going to ultimately end up with 5/128. All right, so that's what we're going to end up with. Let me show you a little bit more. All right, so we have 0.5 cubed minus 3/8 times 0.5 squared minus 0.25 cubed minus 3/8 times 0.25 squared. And then, if we do all that, we'll get 5/128. All right, perfect. So that is our answer. The probability that our stock is less than 1/2, but we sell more than 1/4 of the tank is sold, that probability is 5/128. All right, we'll take a look at our next section next time.